In any introductory calculus class, you'll learn about two main ideas, the derivative and the integral. Well, this is climb time, and in this video, we are going to answer the question, what is the integral? Well, the integral, as it turns out, has two parts to it. So calculus has two parts to it, the derivative and the integral. And the derivative is only one thing, really. It's the slope of the tangent line. But the integral has two parts to it, and they are connected. But the two parts are, one, it is the area underneath the curve, area under, and I'll just say f of x, but it's the area underneath the function. So it's the area between the function and the x-axis. And the second thing is it's the antiderivative. Okay, the antiderivative. So if the derivative goes one way, the antiderivative goes the other way. So the integral basically undoes the derivative. All right, well, let's look at the first part, which is the area underneath the curve. So I have a little example down here. So we have f of x. This is our function. This is y, this is x. Those are your axes. And then I have two spots from A to B. So the way we would write this is we would say the integral, and it looks like this. This is the notation. It looks like an S. It's kind of like an S, and actually that is why it looks the way it does, because it does represent a sum of things. But we would say the integral of f of x dx from A to B. And what that is, it is the area underneath that curve. So it's the area under f of x. When we say under, basically, I mean it's between f of x and the x-axis. So it is this area right here. Okay, so area underneath the curve means between f of x and the x-axis. So when I say under f of x, it means between function and x-axis. Now, there is another possibility, and the possibility is that maybe the function goes up and then it goes down again. So that looks something like this. What happens in that case? Well, the answer there is we actually have some positive area, but we also have some negative area. If that were to happen, this area down here would be considered negative. And the reason why is because the y value is negative. So because we have a negative y value, it produces negative area. And up here, we have positive area. So this is positive. Okay, so this is the first part of what an integral is. An integral is area underneath the curve. And if it's above the x-axis, then it's positive area. If it's below the x-axis, then it's negative area. And the notation for that is we have, this is called an integral, and it looks like an S, and we take the integral of f of x dx. We have two values, an a and a b, and a tells you the starting x value. The b tells you your ending x value. And that gives you the area between those two spots. And we could shade that in, and we can actually find the area. All right, so the second part of the integral is the antiderivative. So antiderivative, let's take a look at that. Antiderivative. All right, so the antiderivative, as the name implies, means it's the opposite of the derivative. So again, the notation is the same. Maybe I'll use a new color this time. The notation is the same. The notation looks like this. I have the integral of f of x dx. And how we often show this when we take the antiderivatives, we make it a capital F of x. And so this right here would be what we call the antiderivative of f. Okay, so what does that mean? That means that if I take the derivative of capital F, I would get little f. Okay, because the derivative of f gives me an antiderivative. So, I'm sorry, not the derivative of f. The integral of f gives me the antiderivative. So therefore, the derivative of capital F, or the antiderivative, leads me back to little f. So when we first learned how to do an operation, back in, I don't know, what is it, first grade or whatnot, you learn how to add. When you first learn how to add, you're like, that's great. When we add two things, it makes a bigger number. But then your question goes to, how do I undo that? If I can add, is there a way to go backwards? And the answer is yes, we learn a new operation. It's called subtraction. And so subtraction is basically going backwards from addition. And when you learn how to multiply, I think that's third grade, then you're like, is there a way to undo that? And then I think it's fourth grade that you learn how to divide, or maybe you still learn how to divide in third grade, but then you learn how to do long division in fourth grade. But you learn how to undo an operation. Every time you learn an operation, you learn how to undo it. So to undo a derivative, we need an antiderivative, which is one of the parts of an integral. So again, the integral has two parts. The first part is the area underneath the curve, and these parts do not seem related to each other, but they are connected, and it's both parts of the integral. So area underneath the curve is one part of the integral, and the second part of the integral is it's the antiderivative. That means if I want to go backwards from a derivative, I do the integral. So the integral of f of x dx, little f of x dx, is equal to capital F of x, which is the antiderivative of f. This just looks like off here, so I'll say of f of x. The antiderivative of f of x. So that means that if I take the derivative of capital F, I get little f. If I take the integral of little f, I get capital F. All right, so those are the two parts of the integral.